Good morning, good afternoon, good evening. What is up, everyone? I am your host, Charlie Shrem, and you're listening and watching another epic episode of The Charlie Shrem Show, powered by Waxman, where together you and I, with the listeners and these awesome guests that we get to dive deep with some of, I guess, Bitcoin, crypto, techs, the most influential leaders of the world right now, those who are in the driver's seat building out all of the products and services that you and I are using right now in tech, and not just tech, but the medical world, the insurance world, homes, politicians, regulators. We have everyone. If you want to understand what's going on in the tech world today, you're following my story, you're listening to the show. And today we're going to learn about the Flare network, and we're going to understand why half the time when you talk to people about blockchains, they're like, well, the oracles, if the oracles aren't decentralized, then what's the point of doing this in the first place? And today we have an awesome guy, Hugo Philion, joins us from Dubai. Hugo, thanks for coming on the show today.
Hey, good to meet you.
You're the CEO of the Flare Network. You have a Master of Science in Machine Learning, super cool. And when we were doing the research for the show, I hadn't known much about Flare beforehand. But you guys are pretty big, robust, huge community, top 100 projects, and I'm like, how did this one fly under my radar? You got this layer one EVM blockchain, but built into your protocol is this like Oracle system, and you can take it from here.
Yeah, so Flare is essentially, I think let's take a step back and say, people in the industry are really trying to deal with scaling right now. If you look at all the roll-ups and things and sharding and stuff that everyone's trying to do, and I get that, and it's a massively useful thing. Um, I think as you started the show, you said people say to you, what's the point of doing all this if the oracles are not decentralized? And really, we started from that premise. Um, and built into Flare as a blockchain um, are essentially two Oracle systems. One is for prices, and so we call that the Flare time series Oracle. It's more formally for time series data, and data specifically that has no single source of truth. Things that have a single source of truth can be dealt with a different protocol. So we have an oracle that is called the Flare time series oracle. Essentially, it's created by the what will eventually be the validators of the network. So every validator will have the right to be an oracle. And in fact, they will not have compensation as a validator unless they provide data to the network. And so ultimately, what we're trying to do is secure a pricing oracle using the structure of the network, right? And then there's a mechanism on top which finds the median of the data, chops out the tails, and those kind of things. But basically, the simple premise of the Flare time series oracle is that if you want to have a highly decentralized and robust pricing source, then you have to use the mechanism in our industry that is itself decentralized, and those are the oracles. And so you run, those are the validators. Run a validator, and you run an oracle on top. So that's the first oracle solution. And so far, we've been operating that on Flare's Canary network called Songbird since September 2021. Our analysis of that oracle shows it to be probably the most decentralized oracle in the space, and more importantly than that, probably arguably the most accurate in
When you
terms
say,
of.
sorry,
Sorry, carry on.
no, please, you.
Just in terms of its closeness to, say, an aggregate of what you might call the major pricing sources.
Is pricing just the beginning though? Like pricing is just what we need now, but for the Flare network and for other blockchains of the world to not just be used for like a tiny cohort of the global population, but for everyone, what other mechanisms, what other type of data need?
Absolutely. So that's really where our second protocol comes in, and this is something we call the state connector. And the state connector essentially has two roles. The first role is that it allows the blockchain at the validator level to come to consensus over the state of another blockchain. So what has happened on Bitcoin? What has happened on Ethereum? What has happened on something like that? And it's I think the hardest thing people find to get their head around is that it's not a pure proof of stake based protocol. Right. So it's very easy to set up a proof of stake network and say, okay,
Yeah.
let's get let's just allow people to make attestations, and let's use a majority rule as to when we offer those attestations in the same way as you would consensus. The problem with that, and actually it's a real bootstrapping problem for proof of stake kind of cross-chain networks, is that if in order for it to be valuable, in order for that blockchain that is doing that job to have security, if it's based purely on proof of stake, it therefore has to be valuable. So this weird chicken and egg problem, right?
Yes.
So who wants to use you because you're not valuable enough to have security, right? And so you've actually see that today with some of the proof of stake messaging networks. They actually have an insufficient amount of stake relative to the amount of TVL that is going across them. And to me, I suppose like many in our industry, we are not overly keen on flawed economic models that are safe until they're not safe. We've seen that, and we don't like that. It's, Luna comes to mind, an economic model that was fine until it wasn't fine. And we feel that's very much that proof of stake is not a protocol that is that works great when it comes to cross-chain value, especially when you're dealing with blockchains and TVL that massively outweighs the stake at risk. So the stake connector is basically built to deviate from the proof of stake mechanism. So its first level of security is proof of stake, but then it has what we call a binary forking protocol, which allows for, if there's a time when the the Ramadan cannon just went off, in case you heard that.
Oh, that's so cool.
Yeah. So that's the that signifies the beginning of iftar, when observant Muslims can go and eat. So anyway, to get back on track, so the state connector allows Flare to come to consensus over the state of what has happened on another blockchain. It uses proof of stake as a first level. Essentially, the validators do that, and they're weighted via they can be weighted via proof of stake, and then it has a second level, which we call a binary forking protocol, which allows secondary observers, so the not validators but network participants, essentially to fall out of consensus with the majority set of validators. That then creates a fork of the network. It's a binary fork. So it doesn't matter what you're objecting to. We may have 10,000 pieces of data that are being attested all in the same round, but anyone who objects to any one of those pieces of data, they can all end up on the same fork. And that means that unlike a proof of stake network where you'd have to get on Telegram and try and restart the network and
break.
It means that you have a clean version of the network in extremis for when or if there is a proof of stake based problem. Much more importantly, because we're talking about cross-chain stuff, every actor on the network can be self-sovereign over what they are doing cross-chain. So to give you an example, let's say on Flare, there's an application that is relying on something that's happening on Ethereum, and you care deeply about that application. You are a participant. Maybe you're a signatory on Ethereum for a multi-sig. So what that allows you to do is it allows you to run your Ethereum node, which you connect to your Flare node, which allows you to make an attestation. You are a local attestation provider in the system. When your local attestation provider does not agree with the majority set of the state connector, you fall out of consensus with it. You and everyone else who is honest. Now, you may, in fact, just be reporting the wrong data and you need to rejoin the network quickly. But assuming the majority set is trying to be malicious, you and everyone else who is honest essentially falls out of the network, forms a new network, can bootstrap that network to gain consensus again, to gain liveness. But most importantly, because you're running your own attestation node, you're not going to make an off-chain action that ends up with you losing money.
So wouldn't you have just all these people like forking constantly? How do you maintain like consensus if there's no?
No, no. So the forking protocol is really an in extremis
Okay.
protocol, right? It's okay. Proof of
But
stake
you've
works
created
works.
like a mechanism for it, I guess, which is important because
It's
other,
yeah,
it's like for every other blockchain out there, it's like if you don't hit consensus, you basically it falls off a cliff. It's like you can't. There's
yeah.
no you. It's like you've created like a surgical mechanism in which you can like remove it and then study it and figure it out after without ruining the network as a whole.
Exactly. That's generally the idea. Is essentially everyone that cares about what's happening off chain and everyone that's running a correct local attestation node, they can fork. The validators can fork with that fork if they want, and the honest ones will. It's basically a defense mechanism against tyranny of the majority of stake. And this makes the stake connector, unlike, say, just a pure proof of stake attestation network, it makes it much more invariant to the value of the transaction.
How do I want to go back to something you said earlier, and because that's what we harp on the show a lot. We talk about this like path to decentralization or like path to immutability, and we discuss it a lot. Various consensus algorithms. We talk about various blockchain networks and protocols, and we study which ones are successful, which ones, kind of are learning from their mistakes, and then which chains are learning from others' mistakes, and so on and so forth. And that proof of stake problem that you just talked about, I want to bring it up again because it's exactly the problem that we have in almost every new blockchain, every new protocol that launches today. So either you're like, so essentially, if you bootstrap these proof of stake blockchains, the problem is that the stake is the mechanism in which you can protect your chain from nefarious actors, but it's also the tool in which the nefarious actor can use to take over your chain. And so you need to be valuable enough to where it's like economically infeasible for someone to take over your chain to try to do something economically incentivized, because then what would be the whole point? You need to be valuable enough where like to buy up all the coins would just be too expensive, and there's something that you can do in the meantime. It needs to be your token liquidity needs to be decentralized enough. There's so many things that need to be in order for you to like get on that path to decentralization without the zombies taking you down before you can get far enough down the path. So what's the solution? Is this the solution?
So, I mean, this isn't a solution to the general proof of stake problem. This is a solution to the tyranny of that problem you describe.
What's the tyranny problem? What do we
So
call
the
it?
tyranny problem, I guess like tyranny of the majority of stake is really what you've got, right? Which is, the stake is meant to be a Sybil resistance mechanism, right? Um, essentially to encourage enough diverse participants to run the network such that you don't end up with malicious
Yeah,
failure.
protects the minority.
um meant to be,
Meant
but
to
the
be.
problem is if you have a poor Satoshi coefficient, because your stake is not distributed widely enough, and it hasn't, I don't know whether it's come to pass much in proof of stake based networks, but it's certainly come to pass in DAOs very strongly that there has been clearly negative consequences of a concentration of, say, DAO voting tokens. Um, so that's really what we're trying to achieve. And what we're trying to achieve as a cross chain network is the ability for. So we take a little bit of inspiration from Stellar here, where the nodes are, the validators are essentially responsible for their own security. It sounds silly, but they have to secure themselves based on their own trust relationships. So we take a little bit of inspiration there. We don't have trust relationships, but we have these local attesters who, if there is a malicious majority of stake, they can essentially deviate from that, resolve the network. But most importantly, they're not making an off-chain action because they're running an attestation node that knows that what the majority set on Flare are reporting is nonsense, and so they're not signing a transaction over on another network where all the value is, um, because they are responsible for securing their own, economic, consequences. And
You
that's a model we've been working on for a long time.
I wanted to ask, I'm going to talk about something else in a second that's going to blow everyone's minds. But I want to ask you though, like, you are you seeing where is the demand for this? Like, you're talking about building one of the most hyper secure, hyper efficient blockchain protocols for data, for oracles, for price. Like, what's your future in 10 years from now? What would you like to see built or switched over or like,
So the
yeah,
so there's a second setting of the state connector, which we call it the web connector. And so we're trying to do three things: great prices, the best blockchain data, right? Good pricing, the best blockchain data, and then there's a sort of solution that the attestation methodology that the state connector allows for, which is essentially massively scalable. Because of the data structure, we can have hundreds of thousands of attestations per round, in that region. And so what we have a third setting, essentially a third oracle which we call the web connector, which allows the state connector to be used in its proof of stake only form to connect to Web 2 data. Again, that won't be as secure as the state connector when it's attesting to blockchain data, because it's proof of stake only.
yeah,
But because it's Web 2 data, and we can't be certain that someone hasn't changed
that's the problem.
it hasn't changed the admin key of the server, or that the server hasn't changed, that the admin hasn't changed what's being represented by the server. So we can't apply the forking protocol to that. But the state connector provides, because of the way it's structured, an extremely good way to quasi-prove data from Web 2 onto Flare. So the demand is as follows. Everyone's rushing towards scaling. Why are they rushing towards scaling? Because DeFi, in reality, it works. Like, it's useful. There's enough money flowing through DeFi to say that we have a very good MVP of a future market for finance.
Wow.
That's why everyone's rushing to scaling. If you take the premise that we have a very good MVP for the future of finance, then absolutely it is a certainty that you need good data. You need to be able to move value across.
Unalterable data too.
Exactly. So good data needs to move value across chains securely. It needs to be economically efficient. If you're economically inefficient, you won't last. And again, things like proof of stake, if you assume the base issue that that you have to have enough stake on a network that is trying to transfer value across chains, then you know that you have to have at least 3 times the TVL. Otherwise, there's at least an incentive to ransom the funds, to
Yeah.
do a liveness attack and ransom the funds. Therefore, you have to have an efficient mechanism by which value can be propagated across chains. And this is kind of what we're trying to approach with Flare.
You mentioned, speaking of efficient, you mentioned something earlier that everyone needs to know about. It's brilliant and it's one of the best tools that if you were to ask me right now, how do I measure the decentralization of a blockchain or a project that I like? How do I do that? And you mentioned this thing called the Nakamoto Coefficient. What is it and how is it used to measure the decentralization of a blockchain?
It's a measure of essentially how many validators form a third of the top 33% of of the chain. Essentially, the measure of how many validators can, I believe, create a liveness attack is my understanding of
So
the
say that again.
Nakamoto
It's
Coefficient.
the measure of
Measure of how many validators
consent.
can create a liveness attack, which in a proof of stake network is 33%.
I'm writing this down. This is really great. And I think
But
that's like some of
just
the
to
most.
be, I want to be absolutely clear though, Flare's Nakamoto coefficient at the moment is very, very poor because we're in beta mode. and staking is coming later this year. What we have is a fantastic distribution to millions of people of our token. And so we are kind of excited that when staking is introduced, that we have, unlike many of the layer ones that have come out in the last couple of years,
Yeah.
we have an extremely wide and broad distribution. We don't have, we don't have like these big whale wallets. We have a very large distribution of moderate size, wallets, and
That's
um,
that's
that's
another important factor for decentralization is that you should look at a project's how many token holders they have, but not just token holders, but like what's the average size of their wallet.
the concentration. If
Yeah.
people have $1, $1 of a token, versus 100 people with a 10 million, it's you have no dispersion.
Part of that path though, and part of that path to full decentralization is the transparency. And the transparency that you've given us today is what is ensuring that Flare is on that path to full decentralization and to have a very high coefficient. A lot of blockchains launch and they just lie and they just start saying that, oh, we're decentralized and you can do all these things, but how many of them are being hacked today? Every day there's another hack or another blockchain that's failing, or man in the middle, or a likeness, or a ransom, or something where where people are losing real money. And until we clean that up, and it starts with transparency.
Well, I mean, we're as transparent as we can be, um, given
Of
regulatory
course, I
demands.
commend you.
But I think from our perspective, look, none of us, and if you look at our team, you'll notice that most of the people on the team could probably earn a very good living in another industry. None of us really got into this just to do a half-assed job.
Wow, you're blowing my mind here. What else? What do I need to know about Flare that I haven't asked yet on a basic level before we get a little bit deeper?
So I think what have we done? Flat time series Oracle, um, state connector, web connector. I mean, generally, look, it's an EVM based layer one. We chose EVM because everyone uses it. Um, it's not it's probably not the best virtual machine out there. But it's not. I think in this industry, you can only choose the area that really interests you. Like some people really interested in scaling, some people really interested in, creating VMs and things like that. And I think ultimately over time, when a great VM comes along that gets massive traction, it's not hard for a blockchain particularly to do a fork if there's community consensus around it
Hmm.
to change VM. All right, it's hard.
Yeah.
It's technically difficult, but it's not impossible. So we chose the EVM because it's literally what everyone uses. It gives us constraints like everyone else, but broadly, we're happy with that choice. What else do we need to cover?
Well, another thing that's really unique about Flare uh, is that a lot of times when you're dealing with a new blockchain, or you're dealing with like a new you're trying to launch like a new system and you're having a token supply, it goes on a test net and then there's like an unlimited supply. So you can't really test the socioeconomic factors of how people will react based on certain like vesting conditions and certain amount of token supply and things like that. So you guys offer this like test net mechanism that then
Oh
you
yeah,
can ease into like being in a main net.
yeah. It's called Songbird, and we spun it up because we wanted to test out the Flare Time series Oracle before it went live on Flare. And we were so so massively excited about what happened with the Flare Time series Oracle. We just put it out there thinking we'd get 5 or 6 oracles. Within 3 or 4 months we had 100. So the maximum size of the oracle set at the moment is 100. just because of the scaling issues with the way that it interacts with the EVM. There's research internally around how to scale that to 1,000 or maybe 5,000, and that research looks to be successful. But very quickly we got to 100 oracles, the maximum number of the set, which was incredibly exciting to see people really engage, provide the data. I was amazed how quickly all the game theoretic kind of
Mm.
stuff came together. All of the like the speed at which the system converged upon a solution was unbelievably exciting. It was amazing to see it go from white paper to reality. And so Songbird offers that for developers. So Songbird offers that as a place to use Flare's protocols, the oracles, the time series oracle, and the state connector, and to essentially test those protocols in a live money environment, but with
Yes, live money environment.
with
That's
a
the
with
key.
a with a beta health warning, right? Like, so it's
Yeah.
like Kusama. It's not novel. It's not something we've done that's that interesting. It's like Kusama, but I guess it allows people to get to grips with exactly what Flare is, how it works, and how the protocol they're building interacts with the protocols that are native to the network.
So cool. Well, Hugo, thank you so much for taking the time and coming on the show today. I really appreciate it.
Oh, my pleasure. Well, one thing we did on the Songbird the other day that was quite fun, just to leave you with this, was that we did a demo where an NFT was purchased on Songbird uh, directly with a payment on Doge.
Really? So
Yeah,
basically you'd have to check the state of Doge, and when a payment is made from Doge wallet to Doge wallet, it unlocks the NFT transfer on Flare. Very cool.
exactly. And that was on Songbird, so that was a good fun demo.
That's the key though. That's what you need. I mean, that's what we need to be able to do on across all sorts of blockchains, and it'll make them a lot harder too. It'll make value you can feel more comfortable and safe moving value from chain to chain.
Yeah, I mean, we also offer this kind of functionality for Bitcoin and a number of other non-smart contract networks. And we put forward a proposal for a bridge, a kind of so we believe that the best way to secure cross-chain transactions is directly with collateral. And we put forward a proposal for a bridge between Bitcoin, Dogecoin, and other non-smart contract networks between them and Flare using collateral, and that's called the F assets. And that's sort of something we hope will come to fruition on Flare.
How would that work? So you put collateral up on the Bitcoin side?
You would put collateral up on the Flare side. So it's quite interesting. It's like we call it a delta hedge synthetic. So it's a bit like, do you know DAI?
Of course.
Of course. So it's like DAI, where the minter, where I guess the person that is creating the vault is separate from the person that is receiving the stablecoin.
Yes.
So we have an agent who puts up collateral on the Flare, and that collateral can be stablecoins, ETH, various other tokens that have come to Flare, and they put up an over collateralized amount. And that agent, when someone then wants to mint, call it Flare Bitcoin, F Bitcoin, an F asset, they send that Bitcoin to the agent who holds an address on the Bitcoin ledger. So they receive the Bitcoin. That Bitcoin is held essentially by the collateral that is on Flare, meaning if they move that Bitcoin, if they steal that Bitcoin, if they don't redeem that Bitcoin,
Yeah.
then their collateral is taken on Flare, and the minter receives the collateral on Flare. And this is about, to our minds, the most trustless solution we could think
Yeah.
of to create a bridge that wasn't just a multi-sig, because the problem with multi-sig bridges is, well, we all know the problem with multi-sig bridges, right? It's you're using a financial institution. Um, and that's why we got into this industry, was to get away from financial institutions. So that's an example of something that can be done with Flare. So, Flare we think is a great substrate for applications that need data. Some of those applications will be cross-chain applications. So interoperability protocols writ large.
Shit, this is the next level of crypto. These are the next applications that are being built. It's like at some point in the future, it's not even going to matter. Like, you're going to have decentralized node infrastructure that's just going to be managing hundreds of different chains. And so how we measure decentralization will become a lot easier in the future. And I think people will shy away from blockchains and protocols that aren't. But this is a really cool crossbridge solution, because probably lately we've been on that theme. We've been talking about how to do that. We've probably talked to a dozen or so projects in the last 6 months that are trying to solve this like cross chain problem, because especially where you have like Ethereum and the like use that EVM account based model. But like you said, Bitcoin and Dogecoin and some of the others, they use this like unspent input and output model, the UTXO model, and it's a completely different. It's like trains that can't operate on the same tracks. So now these solutions using collateral is probably one of the best.
We want it to be as safe and as trustless as possible. That's our
Awesome.
objective.
Hugo, thank you so much. Appreciate
Cool.
you.
My pleasure. My pleasure.